Hey guys, Miss Blake here. We're going to go over part 2 of section P3. All right. So the first thing I want to talk about is conjugates. So all a conjugate is if you have, let's say you had 3 plus the square root of 2. The conjugate is going to be 3 minus the square root of 2. So all it's going to do is it's actually going to get rid of square roots for you. So if you remember from yesterday, we had problems that looked like this, 8 over square root of 3. And it was a big no-no, you couldn't have a square root in the denominator. So to get rid of that, we multiplied by root 3. Now if you look at today's, you can't just multiply by root 5 and make this disappear. Because what's going to happen, if you did, you would wind up with 4 times root 5, and you'd still have a square root in the denominator. So that's when you use a conjugate. So we're going to multiply by the conjugate in the top and the bottom. So 4 plus root 5, the conjugate's going to be 4 minus root 5 in the top and in the bottom. Again, the reason we do it in the top and the bottom is because 4 minus root 5 over 4 minus root 5 is just 1. So we're not changing the value of our number, we're just changing what it looks like. So up top we're going to distribute. 8 times 4 is 32. 8 times negative root 5 is negative 8 root 5. And in the denominator. So with the conjugate, if you FOIL this out, the 4 times negative root 5 and the root 5 times 4, those are going to cancel out for you. So really all you have to look at is 4 times 4 is 16. And root 5 times negative root 5 is going to get you negative 5, right? Root 5 times root 5 is 25. Square root of 25 is 5. And then you just have to simplify that bottom. 32 minus 8 root 5. 16 minus 5 gets me 11. I don't see anything that divides out, so I am done. Again with this, technically you would FOIL. Oops, root 5. I just want you to see the stuff canceling out. If you FOIL this out, you'd have 4 times 4 is 16. 4 times root 5 is negative 4 root 5. Root 5 times 4 is 4 root 5. And root 5 times root 5 is negative square root of 25. I'll write that out just so you see it. Good. And that's where this stuff cancels out. Negative 4 root 5 and positive 4 root 5 are going to cancel out. That's why you use the conjugate. So you have 16 minus 5, and that's what we already talked about. So just so you see it FOILed out, but like I said, the shortcut, you know it's going to be the first 2 and the last 2. Now we're going to move on to higher roots, so higher than a square root. So we're going to talk about cube roots and fourth roots and fifth roots. And you have to understand the concept. So when you're talking about a cube root, you're talking about something times itself times itself. So like 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. Stuff like that. So these are numbers you want to have in mind when you're talking about cube roots. So when I see the cube root of 40, I know I can write it as the cube root of 8 times the cube root of 5. Cube root of 8, again, cube root is 2 because 2 times 2 times 2 gets me 8. And then I don't know the cube root of 5, so I'm going to leave it as the cube root of 5. So you got 2 cube root of 5. Fifth root, now with a fifth root, you're looking for groups of 5. So if you wanted to, you could write this, let's put all these under 1. I'm going to write these as 2. So 8 is 2 times 2 times 2. And then 8 is 2 times 2 times 2. So you want a group of 5 for a fifth root. So we have 1, 2, 3, 4, 5. So if I take the fifth root, I'm going to take out a 2. I still have a fifth root, and it looks like one little 2 is left behind. So we got 2 times the 5th root of 2. Back to cube roots. Remember, you can separate these, so you can write it as the cube root of 125 over the cube root of 27. And again, you know these ones. Cube root of 125 is 5. 5 times 5 times 5 gets me 125. Cube root of 27 is 3. 3 times 3 times 3 is 27. And you get 5 over 3. Subtracting, same concept. You have to have the same roots. So we're going to simplify these. Cube root of 81, I'm going to write it as... I'm going to write it as 3 times 3 times 3 times 3. Because I know that equals 81. Again, cube root, you want a group of 3. So I have 1, 2, 3. So I have one group of 3. So the cube root is going to be 3. 3 times 3 gets me 9 on the outside. And then I still have that 3 all alone inside. Minus 4 cube root of 3. And now that they're the same, you can go ahead and subtract. 9 of them minus 4 of them gives me 5 cube roots of 3. Moving on. Rational exponents. So I always read it as power over root. Power over root. So if you have a rational, a fractional exponent, what's up top is the power you're raising it to, and the bottom is the root you're taking. So you would read this as a square root. So this is really the square root of 25 because we're raising it to the first power, which is 25, and we're taking the square root. So your answer would be 5. Here, power over root, that is the cube root of 8, which is 2. 2 times 2 times 2 gets me 8. Here we have the power over root. This is your 4th root of 81. So you have negative and then 4th root of 81, which is going to be negative 3. Because 3 times 3 times 3 times 3, remember 4th root 4 times, gets me 81, and then that negative's out front. Here your negative's in parentheses. So that is power over root, that is a cube root of negative 8. So the cube root of negative 8 is negative 2, because negative 2 times negative 2 times negative 2 gets me negative 8. Now here you have a negative in the exponent. So remember what that does, that's your reciprocal. So it's 1 over power over root, cube root of 27. And then cube root of 27 is 3. Because 3 times 3 times 3 gets me 27. And we're done. Again, keep that power over root in mind, because they do get a little more complicated. Here we have a power and a root. All the other ones, the power was 1. So let's go ahead and rewrite this. So we're taking the cube root of 27, right? Power over root, and we're raising it to the 4th power. So the cube root of 27 is 3, and we're raising it to the 4th power. 3 to the 4th power gets me 81. Same concept here, power over root. So we're taking a square root of 4, and we're raising it to the 3rd power. Square root of 4 is 2 cubed. 2 times 2 times 2 is 8. And last but not least, again, remember that negative means it's 1 over 32 to the 2/5, right, to make it positive. So we have 1 over, again, power over root, so it's a 5th root of 32 raised to the 2nd power. So we're going to have 1 over, so the 5th root of 32 is 2. because 2 times 2 times 2 times 2 times 2 gets me 32, and squared. So 1 over 4. Example 12. So it gets a little more complicated. This kind of puts everything that we've been learning all together. So we've got 2 times 5 gets me 10. And then remember, when you're multiplying, if they have the same base, you're adding exponents. So we're using those properties of exponents, 4/3 plus 8/3. So we've got 10x 4/3 plus 8/3 is 12/3. And 12 divided by 3 does simplify. We've got x to the 4th. Next one. 20 divided by 5, you can simplify as 4. And remember, division, we subtract. So we're going to have x to the power of 4 minus 3/2. Now remember, to subtract, you've got to have a common denominator. So 4x, I'm going to write this as 4 over 1 minus 3 over 2. So we need a common denominator. It looks like it's going to be 2, so I have to multiply top and bottom by 2. So we've got 4x. This is going to be 8 over 2 minus 3 over 2. Now that we have a common denominator, we can go ahead and subtract. So we've got, I'm going to come up to the top a little bit, 4x, 8/2 minus 3/2 is 5/2. And we're simplified. And last but not least, you can also put them into rational form, exponent form to simplify. So here, there's nothing I can simplify right now because I need a group of 6. I only have 3 of them in here. So you can't simplify anything. But if you put it in exponent form, power over root, so power, oops, no, is 3, and the root is 6. So sometimes putting it in that form, you can actually simplify. So 3/6 is actually 1/2. So remember, power over root, this is actually saying the square root of x. So you can toggle back and forth between exponential and radical form, depending on which one's going to help you. Right now, radical form doesn't help me, but exponential form did. All right, that's all for today. Bye, guys.